We've already thought a lot about powers of 10, so something like 10 to the power 3. So 10 is the base in this example, 3 is the exponent, and this whole thing is a power. That's the nomenclature, and we know that we have to multiply 10 by itself 3 times, because that's the exponent, so that's 10 times 10 times 10, which is 1,000. But we can also expand this to have other bases. So for example, if we have 2 to the power 3, then 2 is the base, 3 is the exponent, and this whole thing is power. So that means that we've got to say do 2 times 2 times 2, multiply the base by itself, the number of times that it says in the exponent, which is 8. And we can have slightly more complicated numbers. So let's say we've got 2/3 to the power 4. So then we've got a fraction as the base, that's fine. We could also have a fraction as the exponent, we'll see that in a minute. And again, this whole thing is a power. So here we've got to multiply 2/3 by itself 4 times, which gives us 16/81. So nothing magical there. So now let's just recap some of the rules that we met for powers of 10, but they apply equally for all these others as well. We're going to talk about 4 of them. So the first one is that a to the power 1, so whatever number we want to the power 1 is equal to 1 over that number. So for example, 4 to the power minus 1 is 1/4, or if I see 1 over 170, then I could equally write that as 170 to the power minus 1. Straightforward enough, I think. How about this one? So a to the power m times a to the power n. So we've got the same base but different exponents, then we can just add together the exponents here. So that's a to the power m plus n. Let's do an example. So if we've got 2 to the power 2 times 2 to the power 3, following this rule, that gives us 2 to the power 2 plus 3, which is 2 to the power 5. But we could equally say this is 2 times 2, and this is 2 times 2 times 2, which gives us 2 to the power 5, which is just the same. And that is in fact equal to 32. On the other hand, if we're dividing two numbers with the same base but different exponents, so let's say a to the power m divided by a to the power n, that gives us a to the power m minus n. So the same idea. So how about if we had 3 to the power 3 divided by 3 to the power 2, for example here. So that gives us, let's spread this out a bit more nicely. So that gives us 3 to the power 3 minus 2, which is 3 to the power 1, which is just 3. But if we were to write it out in full to prove it to ourselves, that would give us this, would give us 3 times 3 times 3 divided by this, which is 3 times 3. And we can cancel these out, which just leaves us 1 3 left. So these are equivalent. And finally, if we've got a to the power m, and we raise that whole thing to the power n, then we can work that out by having a to the power m times n. So for example, if we had 5 squared, and that whole thing squared, so according to this rule we would say 5 to the power 2 times 2, which is 5 to the power 4, which is 625. Or we could say this is 5 squared times 5 squared, because that's how this works. So that would give us 5 times 5 times 5 times 5, which is 5 to the power 4, which is 625. So these are equivalent as well. So these are the rules you have to learn and remember for working with any base, not just base 10, like we were looking at for the scientific notation.